Hi everyone, in this video we are going to practice 5 different oxidation and reduction half reactions. So the very first one we have is fairly straightforward. We're just going to try to identify whether or not these reactions are oxidation or reduction half reactions, and I want you to go ahead and add the electrons in to balance the equation. Go. Alright, did you get an answer? Hopefully you did, but if you didn't, that's okay. We're still practicing here, we're still learning. So the first thing I do when I try to balance these and identify whether or not these half reactions are oxidation or reduction reactions is I try to identify my most positive side. So right away what I see here is that on my reactant side, I have cerium 4+, which is definitely a more positive charge than which I have on my product side, which is cerium 3+. So right away I'm going to try to add electrons to this left side in order to balance the charge. So right now I have positive 4, and I need to make it positive 3 over here. And the only way I can do that is by adding a negative charge, simply by adding a single electron. So -1 plus positive 4 gives me 3+. Definitely balanced in terms of electrons now. The second part is we're trying to identify whether or not it's oxidation or reduction. I see that on my reactant side, my electrons are existing for this half reaction. This is definitely a reduction half reaction, okay? If electrons are on the left side, it's usually a good indication that we're talking about reduction. All right, now for B, what I see here is I have 2+ on my reactant side, 4+, my most positive part, on my product side. So right away, I'm going to try to add electrons to my product side. Now, I have 4+ on my product side, 2+ on my reactant side. In order to balance this charge, I need to add a -2 charge to my product side. So if I add a single electron, that would only bring my charge on my product side back to 3+, but I need to get it down to 2+, so I actually have to add 2 electrons. So remember, an electron has a -1 charge. If we add 2 of them, we actually are adding a 2, so a -2 charge. So 4 plus a -2 actually gives us a +2 charge. So this one now balances out. Now for this one, my electrons are on my right side or my product side, so that is definitely an oxidation reaction. All right, last one. So for this one, it wasn't too hard. Quickly, you can identify that 3 is greater than 2, so we're definitely looking at an oxidation reaction here. We need to add 1 electron to each side in order to balance this out perfectly per atom. Now, what we see here is that we have 5 of our iron 2+, and we have 5 of our iron 3+. So what we need to do is basically consider the fact that we have 5 iron 2+, so 5 of these, okay, so on and so forth, and we have 5 iron 3+. 5 of these. So now, in order to go from here to here, we have to add an electron, but we do this 5 different times. So when we write our overall equation, we don't write +1 electron, we have to write +5 electrons, okay? That is definitely an oxidation reaction. If it doesn't make sense, don't worry about it. Just pause the video for a second and go ahead and reread that and hopefully study a little bit more about that. All right, next question. Here, I again want you to identify whether or not it's oxidation or reduction and also add the electrons. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you have to do here is look at these individually. So I'm going to start with this top one here where I just have my hydrogens. So now what I'm going to do here specifically is I'm going to identify my oxidation numbers. So I see my hydrogen, or H2. Any element in its standard state is always going to have an oxidation number of 0. And now our H+ on our product side is plus, so that has an oxidation state of +1. So I've identified my more positive side to be my product side, and I know I'm going from 0 to +1. There's 2 hydrogen atoms overall, so in order to balance this properly, I need to add an electron, but 2 electrons in order to balance that charge. This is definitely an oxidation half reaction. Now we can look at the second one. We need to assign our oxidation number. So I'm going to start over here with my water. Hydrogen is usually +1. Oxygen is usually -2. Now, if we go over to our reactant side, though, we see that hydrogen, for this example, is definitely +1. But over here, we have oxygen, O2, as a diatomic in its elemental state, definitely going to have an oxidation number of 0. So what we need to do here is balance our oxygen specifically, because it starts off with a value of 0 for an oxidation number, but it ends with a -2. So the only way we can do this is identify our more positive side, add our electrons to the side to try to balance the charge. So now we have 1 oxygen atom. It's going from 0 to -2. The only way we can add our electrons is by adding 2 electrons here. Our electrons are definitely on the left side, the reactant side. This is 100% a reduction half reaction. Now, this would be the first step of a typical problem. What I would ask you to do after identifying oxidation or reduction and after balancing with electrons is to put these two pieces together. Okay, these are your balanced reactions. Put them together for your total chemical equation. So balance this. I want one equation when you add these two together. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. All we're trying to do here is add our reactions together. The first thing we have to do is make sure our electrons cancel. So I see 2 electrons here and 2 electrons here. Those definitely cancel out. We also look and see if there's any other atoms here that we can cancel out. And so what I see is I have 2 hydrogen pluses on my first equation, and I have 2 hydrogen pluses on my second equation. As long as one is on products and one is on reactants, you can cancel them out. Everything else, you just add them up and bring them down. So what I see here is that I'm left over with 1/2 of my oxygen plus H2 gives me water. Always check to make sure that balances. I see 2 hydrogens, 1 oxygen, 1/2 of oxygen 2, which is really just 1 oxygen atom. Definitely balances. Beautiful. All right, so now I want you to try this whole step together. So take copper plus silver, break them up into the half reactions, balance them with electrons, and bring them all together to end up with an overall balanced equation. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you have to do is separate by element. So I see that I have a silver on each side, and I also have a copper on each side. So let's look at our silvers first. The first thing we have to do is I figure out which is my positive component. So my more positive component is going to be on my reactant side here. And so what I'm going to do in order to balance out my charge, I go from a +1 on my reactant side to 0 on my product side. The only way I can do that is by adding a single electron. So now my electrons are balanced for my first half reaction. My electrons are on my left side, so this is definitely a reduction half reaction. All right, so now let's look at the copper. We have copper sitting by itself in its elemental state, definitely with an oxidation charge of 0 or an oxidation number of 0. And then I have my copper 2+ on my product side. So I have 2 on my product side. I need to balance out that charge. It's more positive, so I'm going to have to add 2 electrons going from 0 to 2. The only way I can balance out my charge is this. This is definitely an oxidation reaction. Now, what I see here is that I have 2 electrons in my oxidation half reaction, 1 electron in my reduction half reaction. The only way I can balance this out and properly add them together is I need to multiply my entire silver section by 2. So this becomes, I'm going to rewrite down here, 2 electrons plus 2 silver pluses going to 2 silver zeros. So now I'm going to draw a line here just to separate out. And so now what we have here is we have a new reduction half reaction. Our oxidation reaction hasn't changed. And so now all we're going to do is add everything together to get our overall equation. So now I have 2 electrons and 2 electrons. Those cancel out. Nothing else cancels out, so you just bring it directly down. So copper 0 plus 2 silver pluses going to copper 2 plus 2 silvers. Definitely have a balanced reaction. Good. Hopefully that makes sense. Last one, plow through it. Go. All right, did you get an answer? Hopefully you did. This was the hardest one that we did today. So if you got stuck, do not worry about it. This was definitely challenging. So the first thing you have to do is go through and identify your oxidation numbers. So hydrogen is usually +1. There's 4 of them here. So +1 times 4 gives us +4. That means our carbon has to be -4. That's probably something we're going to look at later. Go back to our next one. So our oxygen -2. Hydrogen usually +1. -2 plus 1 gives us an overall charge of -1. That definitely balances out. Now move to carbon dioxide. Oxygen is normally -2, but there's 2 atoms, so -2 times 2 gives me -4 overall. In order to end up with an overall charge of 0, a neutral charge for carbon dioxide, our carbon definitely has to go to +4. Definitely changed. It went from -4 to +4, but we still have to balance out our water. Water is always +1 on our hydrogen and -2 on our oxygen. So what we see here is that our carbon goes from -4 to +4. But before we can balance those electrons, we have to balance our overall equation. That is always the first step. And so if you do this properly, I'd give you some time to do it, but if you do it properly, hopefully what you ended up with is you have an 8 in front of your OH-, and then you have a 6 in front of your water. Now, it didn't do anything with our carbon, so we don't have to adjust our electron count. But what we see is that it went from -4 to +4. We see that our +4 is on the product side, so we definitely have to add electrons to our positive side. The only way to do this properly is by adding 8 electrons total, 8 electrons. Now, we have to do the same thing for the second one. So we see oxygen has an overall charge of 0. Water, like we said before, +1 for hydrogen, -2 for oxygen. Then our OH-, same thing as before, -2 on our oxygen and +1 on our hydrogen. So what we see here is that our oxygen has gone from 0 to -2. But now, before we do anything, we have to balance this equation. If we do this properly, you would end up with a 2 in front of your water and a 4 in front of your hydroxide ion. So now, again, it didn't change anything for our diatomic oxygen, but it did change our other oxygen. This is the trickiest part. What you need to see here is that 2 of your oxygens are already at -2, but 2 of them are at oxygen at 0. And so what we have to do is figure out a way to balance just 2 of our oxygens, because 2 of them have gone from 0 to -2. So what that means is we need to add an overall of 2 electrons on each side per oxygen. There's 2 oxygen atoms that change, so it's actually a total of 4 electrons. All right, so we're so close to being done. We're not there yet. But what we see here is that we have 4 electrons on our reduction half reaction, 8 electrons on our oxidation half reaction. The only way we can balance it is by multiplying this entire section by 2. So I'm going to rewrite it down here. We end up with 8 electrons plus 2 O2 plus 4 H2O going to 8 OH minus. So now I'm going to draw a small line through here so we just remember to ignore it. Now the very, very last step, the last thing we have to do is we add both our oxidation and our reduction half reaction together. The first thing we see is that our 8 electrons cancel each other out. So this one is gone and this one's gone. Now we can look at everything else. We see that we have 8 hydroxide ions on each side, so that's going to go away as well. I see that we have 4 waters here, so 4 are going to go away, but we're going to be left with 2 over here. Now everything else we can bring down, and so what we end up, if you did this all properly, was CH4 plus 2 O2 going to CO2 plus 2 H2O. Whew, that was a big one. That's a long one. Please take some time and work through that if you weren't able to get it. But if you can do this problem, you're going to be 100% fine on the exam. Good luck, take care of yourself, and make sure you drink that water.